Hi, and welcome to another episode of Ox Valley Home Projects. Today I want to show you how I design 3D objects. Most people do it in programs like Fusion 360 or even Google SketchUp. I use OpenScad because I'm a programmer. I want to show you how this boat is created. It's two parts. One part and another part. It is used for keeping the avocado seed not completely in the water. When I created this boat, it has a special feature. Not often do you need to have something else than squares, spheres, or cylinders. But the boat shape is a little different, so I used a tool I made myself. So, let's start showing how I made this boat.
So, to make the beginning of the boat, I draw something on the paper. I want to find the coordinates for this. So I start here. I try to do it better than the drawing. That's why I'm not exactly on the line, but I put them together as many as I like, as long as we get the shape right. And when it's a bend, you should have more, not as far apart if it's a bend. Every dot has the coordinates. You can look at them. Let's do the rest of them. Okay, that's enough. Let's make G for generate. This is what we get. The beginning. We get all the coordinates in a OpenScad project. We can start working with it. First, I will correct all the lines, not make it so wobbly. So this is the complete program. It makes this boat in two parts. And this is all it is. It's first 50 coordinates from the program, and then about another 150 lines of code that makes it all. I'm going to go through all the code now to see what does what in this. What you see now is the inner piece called core and the boat. So let's make this invisible. This is the boat. Let's start with the boat. The boat is built up by many pieces. First, we have this shape we made with the software, these coordinates. If you want to see the coordinates, they look like this. It's called shape here. F5. This is the shape. It connects the last dot with the first dot and makes this shape. It's kind of half a boat. And since it is half, we need next module that takes the shape and make a mirror image of it with another shape. Then of course it looks like this. This is kind of a bit of the boat. And in the next step, take this double shape and we take another looking like it, but only 90% as large, and put it inside and say, let's cut this piece out. Then it is called ring shape. Looks like this. The piece we cut out by a percentage here, we can see it. Let's remove the blue so we can see what's really going on. This is a yellow one, and this is what I cut out, this gray kind of see-through thing in the middle. Makes this shape. So now we have this shape, but we need a boat. What do we do next? We take a lot of ring shapes. I want it 52 millimeters high. So I say, let's go for a loop from 0 to 52. And this is the factor how much each level should raise above next level. So if we do this, only this, we have to cut out a lot of other stuff. Let's take this and just show this part. Remove the ring shape. And this is all, you see they are moved just a little. They are scaled a bit, so every piece will be less and less. And next step, we put a shape in the bottom, a double shape that isn't any holes in it. And we also add a green cylinder. Let's show the boat. Put it like this. It's the shapes, the end shape down here, and the green, I made it green, this cylinder in here. And I remove another cylinder inside that, so we can have a hole in it. This is the remove part. This is what I remove from the inside. Yeah, and then you see all these knobs, sounds, looks kind of tedious to make. But I will explain them. It starts with a nab. Let's show a nab. Nab is here. It's basically only a cube. Go to view one. Here is a nab. Let's remove the boat. This is a nab. It's an ordinary cube. I didn't have to have a whole module like this to create a nab because it's only a cube. But it has one advantage, and I will show you later when we put these around the ring. Next step, we need nabs all over the place. If I make all these disappear, let's remove the nab and show the boat again. Here is the boat with no nabs inside here. It's just a cylinder. And then let's show me what I did. I took a loop from 0 to 120 degrees. That's a third of a total circle. And I place 3 nabs at the position, and with 120 differs in the angle. So if I place 1 here, place 1, I put them here, a lot of squares. And next, here and here, then they are all, we will remove all this in the light gray color. And let's do that. So they are removed. So now everything is fine, except these are so long. We just need them very short. So let's make another nab upon them to cut them out. Like this. I cut them the same size, not very high. And do this for all 3 angles. So we get the full circle. Now they will cut this out. And if I do that, they look like this. We have this system. And I will discuss the angles and position of all the cubes when I go to the next part, the core part. Let's show the core, the inside. This is the inside. It looks like this. And it's built up with a few things. Core, we have the nabs. We can, for now, don't look at the inside. We only have the nabs. And how can you find where to place them and in what angle they should be? Yeah, that's where geometry comes in. If I say place nab 0, we put them in position. This is always the same when you do it. When you have an angle, the X position is sinus of the angle, and the Y position is the cosinus of the angle. That's all you need to do to place something in a circle. So this is what we do here. We put in an angle, and then we realize where on this ring this should be put. And also, an important part, what angle should this cube have? If we didn't have any angle, it would look like this. They would look the same. Yeah, and the inside is removed, so we don't see it. But you also have to rotate, and that is in the same angle as everything. There is one more part about this nab. You don't just take a cube, as I have here, and show it, because if you do, this is what you get. Seems kind of right, but if you look closely, it's not keeping on here. They are all the same. So why is that? Yeah, that's because when you rotate something, it's rotated around one corner of a cube. So this is the position stuck to the element and the rest is rotating. And what do we really want? We want something that rotates here. It's stuck here and the rest is rotating. So I make this. I make a cube and I translate it half the width, this area. This, I move it there and I put the cube there and I get this change of result. So that's the nabs and how the sinus and cosinus works. And this is the place nabs we also use for removing stuff in the outer circle when we made this stair. And then it's only one part more. We make a triangle, 3 positions from 0 to the height. It's just down in a straight line and then out a bit from the center. So then it looks like this. Can you see the triangle? It's from the top, straight line to the bottom, and then out a bit. And when we had 3 and say make a shape, it takes the last one and put it back on the first one. So we get this triangle. But it's a flat triangle. What we need then is the line extrude. So this means make it 2.5 millimeters thick. So we have one triangle called 3 because it's a triangle. And what do you do with this? We make this again. I have here a folder. I liked 10 is about a good amount to have here. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go around the circle from 0 to 360, and each step is 36. But in this formula like this. And how to place something in a circle, we know now. We just take sinus of the angle for x and cosinus on the angle for y. And then don't forget to rotate. If we didn't rotate, it would look like this. Not exactly what we want. So we have to rotate as well, and in the same angle. So here we have it, the inside, the boat in the outside. Let's put them together again. So this is every part we needed. 200 lines of code. So this is the way I build 3D models.
Yeah, that's the way I do 3D objects. And that's the end of this episode. Bye bye.